E to the 0 is 1. What does this mean? I'm going to box it. What does 1 over 0 mean?
It doesn't exist.
Good. Your answer is DNA. I'm putting all kinds of problems that could show up tomorrow just so you have a plethora of things to look at for your cheat sheet. I'm going to give you one more and then a reminder of something. Am I good to keep going?
Wait, for that last one,
Yep.
couldn't you take the derivative one more time and then the limit would be 1/2?
You could, but the problem is in order to take L'Hopital, you have to be in the
Oh,
form.
right. Right.
Yes. That's a good question, though. I'm pretty sure you have to be in the form. Yeah. Other questions?
I don't believe so.
Okay, let's keep going. I have one more, like I said. This is 28. 28. And this is the limit as x approaches infinity of natural log of x over x. This is our first infinity. What does this look like? What's my first step?
Like infinity?
Yep. Good. And what's my top going towards?
Infinity, if I'm not mistaken.
Correct. Good. And the bottom?
Just straight up infinity.
Great. Good. So that means we're good to go. I threw one of these in there just to remind you infinity exists. L'Hopital, what's my derivative of natural log of x?
1 over x.
Beautiful. And what's the derivative of x?
1.
Good.
So would this be x over 1?
It wouldn't be x over, because I have my 1 on my bottom, it just simplifies to be 1 over x.
Oh, okay.
So now a reminder, I'm taking the limit as x approaches infinity. I'm not practicing good notation, sorry. What do I do now?
Plug it back in.
Yep. What is my answer when I have 1 over infinity? Always.
0.
Yeah, write this down. This is important. Big stars, 1,000 stars. You don't want to say infinity there. Good. So this might pop up.
It's so small.
Exactly. It's blowing up in the bottom, which makes it super, super tiny. Good. Questions on that one?
Pretty good.
Okay. I'm going to give you a little tidbit to look back and put on your sheet. So put on sheet. We did a problem in the notes. I don't remember what day or what week, but we had the limit as x approaches, x approaches 0 from the right of x to the x. And he showed this about 3 times, so something tells me this is going to be on the exam tomorrow. And reminder, we use natural log. We did natural log of y equals x natural log of x, because when you add natural log, you can bring down this power to the front, which is what we did over here. I'm not going to go through the whole thing, but it's in your notes. Put this on your sheet, because something tells me he's going to throw something with that natural log business, and we want to just be prepared. Does that sound good?
Mm-hmm.
Okay. Great. Questions on L'Hopitals before we move on to our final section?
Okay, so I wasn't paying attention. So for that bottom part, it's if it's an x to the x, just start throwing ln's.
Yes.
Okay.
So, and exactly. So anything that you have an exponent that you don't know what to deal with. So here.
It's 5 to the x or whatever.
Yeah, exactly. Exactly. You want to put the natural log in the front. Yes, you can, Colin.
Throwing ln's, all right.
Yep. Exactly. Because then it brings it out front, which, as you see where I'm underlining in red, that's much easier to deal with than what we were dealing with before. And then in the notes, it talks about in order to get rid of ln, you raise it to the e. E and ln are each other's opposites. So then somehow you get this. That, again, in the notes, you have it done out a few times. But just want to remind you that it exists.
Okay.
Cool. I'm going to go on to our final section. This is not a section that's meant to trip you up. It's just a notation type thing. Improper fractions. I'm sorry, improper integrals. All it means is you have a domain issue. Oh, my handwriting. I'm so sorry. Domain issue. So you have one of two things going on. You have infinity, positive or negative infinity in your bounds. Or you have like 1 over x, something with your bounds. So we're going to do an example. I'm going to show you. Can I erase what I just wrote, or are we still writing this?
Still writing.
Okay, I'll wait.
So plus or minus infinity in bounds and 1 over x out of bounds.
1 over x being that the bounds make x equal 0. That's a good point. We don't want our denominator equal to 0. I'm going to show you. I'll do an example right now. So, like, you could have 1 to 3, and you have 1 over x minus 2. 2 is between 1 and 3, right? But 1 over 0 is a big no-no. And so you would need to use improper here. Does that make sense?
Wait, so I wasn't paying attention. So
That's okay. So I'm doing this case scenario number 2,
Yep.
where you have 1 over x minus 2, and I'm saying go from 1 to 3. And
Yep.
I'm saying, look at my denominator. If I were to do 2, which lives in this A to B, I would get 1 over 0, which is a big no-no.
yeah,
So you would need an improper for that. Am I good to go on to the next thing?
okay, that makes sense.
Second.
Actually, okay, there we go. Those are bounds. I didn't realize.
Am I good to go?
1 second.
Yep.
Okay, good.
Okay. I'm just going to erase this page because I'm running out of the 12 that they give me. It's just a little bit. Okay.
Why would they only give me 12 pages?
I don't know, but it's really annoying. They're not think of us math people.
So
So
they give you a random limit for no real reason?
yeah, I don't know. I heard a wait.
Is the new content that we were supposed to learn this week, is that going to be on the test?
No.
Perfect.
Yeah. Yeah, no, I thought it was too, but his review went up before it got posted. Okay, so number 8, we have from 1 to infinity of 1 over x cubed. Now that's something we know how to work with, right? This is not, that's why I chose this one to show the material. See that infinity on the top? That's where we need to do some work. We're going to rewrite this to be the limit as b approaches infinity. And why am I choosing b? Reminder that we're going from a to b. So I'm just trying to keep it kind of. It doesn't really matter what b is. You could name it carrot for all I care, right? It just you just have to have it. Yeah. So 1 to b. B is usually what we try to do, and a on the bottom. X cubed dx. Now I take my derivative, antiderivative, the way I normally would. I'm going to rewrite that one more time. Oh, boy, what am I doing? The limit is, oh no. The limit as b approaches infinity of the integral of 1 to b of x to the negative 3 dx. Notice where I went from first step to the second step because I know I'm going to need that in order to do my antiderivative. What does my antiderivative look like?
It's okay. Hold on. It's x. It has a to the negative 2. I'll tell you that much.
Love it.
Negative 1/2.
Yep.
Thank you.
Good. So you can rewrite it. Oh, I have it right here in the negative 1/2. Notice I'm carrying my limit sign down. We need that. Okay. And then I go from 1 to b. Now we evaluate it just like how we would in the past. And when we plug in the b, we have to attach the limit value. So watch how I do it. I do the limit as b approaches infinity of b to the negative 2 minus the limit as b approaches infinity of, 1 to the negative 2 all over negative 2. Oh, I forgot the negative 2 right there. Okay.
So wait, so that's b to the negative 2 over negative 2 minus.
Yep.
Was that 1? All right.
Yeah. Can I go on to the next page? I'm writing kind of big. Yep. Oh wait.
Okay, so just to reiterate, what he basically did was replace the infinity with a b, turn it into a limit.
Yep.
Integrate it as you normally would.
Yep.
And then just turning it into a limit.
That's exactly it. You're turning it into a limit problem.
Okay, cool.
Exactly. Good.
So
Okay. Oh, go
I
ahead.
got the limit was 1/2. Is that
Yep, that's correct.
okay?
Oh, okay.
We're gonna solve this now.
Yeah,
So-
shut up, please.
Yeah, so let's go on to a new page. We have where's it on my sheet? The limit, I'm going to rewrite it a little bit. As b approaches infinity, I'm going to make it that negative 1/2. Now, b to the negative 2, write it right here, b to the negative 2, that's equal to 1 over b squared. Reminder that when you have that negative in the power, that means put it in your bottom. And that's going to help us here. 1 over b squared. Minus, I have no b's in the second part, so all I'm concerned with is that negative 1/2 times 1 to the negative 2. What's 1 to any power?
1.
Good. So we're just going to rewrite that now. We don't need to worry about that.
Okay.
If I plug... Oh, go ahead.
Okay, I'm so scattered right now, so just reiterate that again. So the limit... I'm just taking algebraic steps from the last step that we just did. Okay.
Are you okay with how I rewrote b to the negative 2? The same way that we got to negative 3. We started our problem with 1 over x cubed, and then I said, remember how we can rewrite this to look like this?
Yeah.
That's what we did. We reversed it. We said, let's pretend that we only have x to the negative 3. Let's rewrite that.
Okay, now I get it. But,
Okay.
just so I know, where did the negative 1/2 come from? Is that just from the,
the other side had this.
Okay, cool.
And so I just rewrote it. That's a good question, though. Good. Now, when I plug in infinity here, let's worry about our limit. So the limit as b approaches infinity, negative 1/2 is not going to happen. 1 over infinity squared. What does that go to? What's 1 over infinity, the limit?
0.
Good. So this whole thing goes to 0. So all I'm left with is minus a negative 1/2, because it's 0 minus that. What's minus and minus?
Positive.
Yeah, so it's going to be what? What's our answer?
1/2.
That's it.
Okay, now I get. So you were just pulling out 1/2, basically.
Exactly. Good. So this is how you would set up a improper. I'm going to set up one more. I'm not going to solve it for you. But the process is what I'm more concerned about. So let's go on to the next one. This is number 10 in your book. We have negative infinity to infinity. Right there of 1 over x squared plus 9. This is a reminder. This is a bunch of reminders in this one. When you have 2, that means you need to break it up twice. Okay? So that means I'm going to break it up for you. Doesn't matter which one you start with. I like to start with A. So the limit as my bottom approaches negative infinity of A, and then I have to choose some number that I can break it up. I don't care if it's 55. I don't care if it's 6. I don't care if it's negative 100. Doesn't matter as long as you break it up at the same spot. Where do we always want to break it? 0. Unless you can't break it at 0, you want it at 0 or 1, because then your life becomes way easier. 1 over x squared plus 9 dx. We're going to keep going, plus the limit as b approaches my top, which is infinity, that same number to b of the same integral. This is kind of weird. Have we seen this before? I don't remember if we did this in class.
I don't think so.
Okay. This is a good one to write down. I'm not sure if we got a full improper because of spring break and all that and the snow and whatever it was, but I'd write this one down. Now we take the antiderivative the same way, and I'm gonna underline this. Who knows what this is?
Arctan.
What's this in? You got it. I put this on here to remind you that that's going to show up again. Carry down limit. Oh my goodness, why is my colors changing? A goes to negative infinity of arctan, and it's 1/3 arc, right? Arctan of x over 3. I think. Plus the limit is b. This is a formula, if you're wondering, of 1/3 arctan of x over 3. And for sake of time, I'm not going to go through the formula. So this first one's going to be evaluated a to 0, and the second one's going to be evaluated 0 to b. This just takes attention to detail, right? We're taking it one step at a time. We have a in one and b in the other. I'm not going to try to do this together. I have to separate them. Does that make sense what I mean by separate them?
Mm-hmm.
Okay. I'm going to go on to the next page. Am I good to keep going?
Yeah.
Okay.
Yeah.
So my next page, we're going to start with the first one. I'm just going to write a little one. A little one black. I want 1/3 arctan of 0 minus the limit as a approaches negative infinity of arctan of negative infinity. Now, should I have that limit out front? Oh, and there should be a 1/3 there too. I'm sorry. I could have my limit here too, but you don't really need it. If you don't know what these answers are, your graph is your best friend. Arctan graph wouldn't be a bad idea to throw a tiny, tiny, tiny version on your cheat sheet. I really wouldn't stress too much about having a detailed version. But arctan of 0 is 0. So 1/3 times 0. I'm not pulling that from like knowledge that we know. I'm looking at a graph when I do that, just so you know. When I go to negative infinity, I go to negative pi over 2, forever and always. Okay? So this means that my first one goes to 0. I'm kind of rushing through this now. This is going to be equal to pi over 6. My first part. This is not the answer. This is part 1. Part 2 is 1/3 limit is b goes to infinity of arctan of b over 3, which is infinity over 3. We can just write that infinity over 3. Minus arctan of 0. Oh, I'm sorry, 1/3 arctan of 0. Now I'm like rushing. We already talked about arctan of 0 goes to 0, so don't worry about that. This first piece here, arctan of infinity, is pi over 2. Okay, so this is equal to pi over 6.
Is that
And I know they're not always. Go ahead.
pi over 2 coming off the graph you have up?
Yes. Yep.
Okay.
This pi over 2, let's write a little note, graph. Same thing here, graph. I would not know that off the top of my head. Your calculator might be able to figure it out too. I'm just depending on what calculator. So I'm going to box in yellow part A and part B. Add those together for your final answer. So pi over 6 plus pi over 6, which equals 2 pi over 6 or pi over 3. And that's your answer. That's a lot. What's important from this, right? Reminder that arctan exists. That's important. Reminder to look through the book to find those ahead of time. And then part 2 is how do we break up two infinities? Can I go back to the previous page?
Yeah.
Yeah. If I can find my work. We want to break it up twice, right? This is a good reminder that on how we break it up by putting the 0 in between. I'm more concerned about the process. How do we feel about the process?
Good.
Good. Do we have questions? I'm going to open the floor for questions.
What's the cheat sheet policy for this exam? Just the 1 8.5 by 11?
Correct.
Okay, cool.
I don't know if he said double-sided or not. I don't remember.
Okay.
Does anyone know? I don't think he cared last time.
I think
Scan
we
it
always
on
assume
cheat sheet too.
Say it again, Lexi.
I
Or
was
Lauren,
just
whoever
gonna
just spoke.
say, last year, or last exam, he didn't care if it was double-sided or not, but recommended not to.
Because
Right.
it wastes time.
That was what I thought.
Yeah, do
Correct.
we have to scan
So-
in like our cheat sheet as well?
Probably.
Right,
It-
Bridget asked that. I would say probably. I
Okay.
don't know. I feel like it doesn't hurt to scan it in.
Okay. And then if we don't have a scanner, does like my phone
Picture.
has like an Evernote, like it can kind of scan?
Yep.
That's
Yep.
fine.
I would say that or picture. I've just done picture before.
Okay.
Take home.
Anything that ends
Um,
up as a PDF though?
Exactly.
Cool.
So essentially, with improper integrals, you're just replacing infinity with b, for example,
Yep.
and then doing it out as you normally would with any other limit or integral, and then just pushing it back out to infinity, essentially.
That's exactly it. Yeah, exactly. And then treating it as a limit problem, like is what you had said. Exactly what you're doing is treating it like a limit problem.
Alicia, sorry, I
Yep.
didn't mean to interrupt. Are
That's
there
okay.
things like, I mean, obviously the general topics you would recommend having on there, and then like the unit circle if you're not very comfortable with that. What are some other like either reminders? Like I know last time you said to like write the plus C, and I wrote it down, and that helps me. And like, are there
Oh, yeah.
other things you
I
would
write the plus
recommend
C.
writing? Like, don't forget to do
Yeah.
this. Like, just are there other things?
Let me think. I don't know if this is on your sheet, depending on how you are, but show your work.
Okay.
This unit is all meticulous work, right? Like, I mean, you saw how many whiteboards I went through, 24. This is all meticulous work, so I would write to remind yourself to show every step because you want all the points and circle where you are. The plus C is always something to remind yourself of. I think I'm going to go back to L'Hopital. Check. Remind yourself to check every time, because there was a time where we were like, hey, well, we could just like keep going, and then we're like, wait a second, it doesn't meet the criteria. And I really feel like he's going to try to trick you on that, because L'Hopital is pretty straightforward. After practice, like we all were like, oh yeah, I've seen this before. I'm okay with this, but I feel like he's going to try to trick you. So if you check your work, then you're going to be okay.
Is it going to be just one that you won't even need the thing like anymore for L'Hopital, honestly?
So I wouldn't be shocked. I've never worked with Dr. Gray in this class, but I really wouldn't be shocked if one shows up.
Okay.
I think that we did one earlier in the problem where we got 1 over 0. I really wouldn't be shocked. When we did classwork, I forget which section I was in, I think the 1230, there was one that popped up in it. Other questions?
Don't believe I have any.
Thank you, Alicia.
Yeah, my pleasure. Before we go, I'm going to put my face back up. Don't go yet. Where's my face? Stop share. Okay. 2 things. So I'm going to continue doing a weekly review. It won't be at this time because I normally am in staff meeting, but I'm going to do it on Mondays at 2. So the hope is that you're not all in class at that point. Are you doing a synchronous class at that time? Who would want to join?
I do.
I'm seeing some. Okay, I'm seeing a lot of head nods.
Wait, what was the question? Sorry.
I'd like to do a weekly review session.
Oh, okay.
But the question is right now it's Mondays at 2, but the hope was that people weren't going to have online classes at that time. But it seems that a good majority just raised their hand for that.
I don't, but I hear there's others who do, so.
Okay. Let me look into another time and I'll get back to you all. Does that sound good? Would that be something that would be helpful?
Yeah.
I'm
Yeah,
very
okay.
interested in that.
That'd be big. That'd be big
Yeah.
helpful, as they
Do
say.
Thursdays work?
Yeah.
Thursdays are.
Thursday?
Yeah.
I can't do the
Yeah,
12:30 period. What about Thursdays at 11? Would Thursdays at 11 work for people?
I have another, I have a 1-to-1 at that time.
You have the
I
one
have a
about-
non-synchronous class at that time, so.
Okay, what about Thursdays at 10?
Okay, that kind of
That's
works.
fine.
I'm seeing some laughs as if, no, I have class all the time. Thursdays at 10?
That's so early.
I just don't.
No.
It kind of works because the class at 11 I have at 11 isn't synchronous. So
Oh wait, I have an idea. Can we do Thursdays at 12:30? I mean Tuesdays at 12:30. Isn't that when the class is?
I love that plan.
Thursday,
Yeah.
we
I was gonna say, why just have it on class time?
Right. So the problem is there's people who are in the 9:30 section, so I don't know if they have a 12:30.
Was it Tuesday at 12:30?
Yeah. Do people have class then that would be interested in attending?
I'm interested.
Yeah,
I would have
that's fine.
Tuesday.
I'm fine.
That's good.
So Tuesdays at 12:30.
That'd work perfect.
Tuesdays at 12:30. I will send out something on Monday. Let's not deal with it until after the test. But Tuesday we'll start and we'll start worrying about the material that we were dealt with this week. So that sound good?
Yeah.
If you, it's all optional. It's like this. You can come. You don't have to come. You don't have to stay the whole time. You can do whatever you need to. It'll be an hour. The other thing is too is I'm gonna read off first names. If I don't have your first name, just let me know, just so you get a credit for attending this, right? So I have Emily, Dakota, Noah, Olivia, Kelsey, Jason, Nick, Nate, Lexi, Dylan, Ainsley, Raymond, Bridget, Henry, Lauren, Colin, Morgan. Did I forget anybody?
Half the class.
Yeah. Truly, Morgan, I don't have your last name. Do you have? What's your last name?
Godin.
Oh, sorry, you cut out. Can you say it one more time?
It's Godin. Goding.
Perfect. Perfect. If you have never oh, Kyle, thank you. Got you. And I got your last name. Thank you. If you have never visited the Learning Center, this is like weird. We usually have a sign-in sheet, and I don't have a sign-in sheet, and I'm not allowed to take IDs with more than one person in the room. So, like, I got someone's ID when they came in first. If you can shoot me an email with your ID, that would be great, just to me. And so then it stays between us what your ID is. If you've been to the Learning Center or if you work at the Learning Center, we got your ID. So you're good. That sound good? Yeah, if you've been there, you're good. At least once.
Just message you
in
on
your
here.
entire life.
Yeah, I've been there twice.
No, send it to my email. So my email, the one that you got this link from.
Okay.
I've been there like half a dozen times.
Say that again?
Yeah, I've been there like half a dozen times.
Yeah, if you've been there at least once, you're never having to send it again. I have it. I just need it for the new people. Okay.
Dude.
I